Something about this should bother you. Every day you look at a clock, wait a few minutes, remember the past, make plans for the future, and believe, almost without noticing, that time is the invisible stage on which all reality unfolds. It feels so natural that we rarely question its existence. But here is the question that completely shatters this sense of security. What if time simply does not exist the way we imagine it? What if past, present, and future are not separate moments, but parts of a single gigantic structure where everything already exists at once? If this possibility is correct, then perhaps reality itself is far more different than what our minds were built to perceive. The idea seems absurd only because all our experience depends on the sensation of continuous motion. You feel your heart beating, you watch the sun rise, you see people aging, and you believe these events are being produced by some invisible river called time. However, when physics began to investigate the universe at its deepest scales, it discovered something uncomfortable. Many of the fundamental laws simply do not treat time the way common sense imagines. This is the great promise of our journey today. We will follow a seemingly simple question to a place where space, matter, gravity, and consciousness begin to blend in unexpected ways. And perhaps by the end, the initial question will no longer make sense. If you are new here, welcome. Subscribe and get comfortable, because today we will follow this question as far as it can take us. Part 1. Imagine you are watching a movie. To you, each scene happens after the previous one. The characters live in a present that feels real. There is suspense, surprise, and anticipation. But for someone holding the entire film reel, all scenes already exist simultaneously. The beginning, the middle, and the end are present at the same time. Only the observer, frame by frame, experiences the sensation of time passing. This comparison may seem like just a metaphor, but it comes close to one of the most intriguing interpretations produced by modern physics. Intuition would suggest one thing, but physics shows another. For centuries, we believed time was absolute, a kind of universal clock functioning the same way across the entire cosmos. This view seemed to work perfectly to explain planets, falling objects, and everyday motion. Then a problem emerged: light. Experiments showed that the speed of light remained exactly the same, regardless of the observer's motion. This seemed impossible. If someone runs after a train, relative speed changes. If one car overtakes another, each driver measures different speeds. But light simply refused to obey this logic. Then came one of the greatest revolutions in the history of science: relativity. According to this theory, it is not light that changes to accommodate the universe. It is space itself and time itself that change to accommodate light. This statement seems simple until you think about it long enough. It means that two observers can disagree about how much time passed between two events, and yet both can be absolutely correct. Time is no longer a universal entity. It becomes dependent on motion and gravity. This is not philosophy. This is exactly what happens with satellites orbiting Earth. The clocks on them tick at a slightly different rate than clocks on the planet's surface. If this difference were not constantly corrected, GPS navigation systems would accumulate errors of kilometers within hours. The key detail is that these clocks are not malfunctioning. They truly experience time differently, but this is still only the surface. Now consider an astronaut traveling close to the speed of light. For them, a few years could pass while decades or even centuries pass on Earth. There is no universal clock telling who is right. Each trajectory creates its own experience of time. The problem becomes even stranger when we look at gravity. Imagine a heavy ball placed on a stretched sheet. The ball bends the fabric and changes all paths around it. This image is often used to represent gravity, but there is a detail almost no one notices. The fabric does not represent only space, it represents spacetime. This means that large concentrations of mass do not only curve distances, they curve the very passage of time itself. The stronger the gravity, the more slowly time flows compared to regions where gravity is weaker. That is why a black hole is not just a gravitational machine. It is a laboratory where our intuitive notion of past and future begins to lose meaning. Near the event horizon, a distant observer would see a clock slow down continuously, almost as if time were freezing. For the one falling in, however, nothing seems extraordinary in that moment. This contradiction does not arise because physics is wrong. It arises because our intuition was shaped to survive on the surface of a small planet, not to understand objects capable of deforming the very fabric of reality. But here is the problem. Even accepting all of this, we are still assuming that time exists. We are only saying that it passes faster or slower. What if that assumption has been wrong from the very beginning? This question takes us to a much deeper layer. Some physicists describe the universe as a four-dimensional block, where space and time form a single inseparable structure. In this view, informally called the block universe, past, present, and future do not appear or disappear. They simply exist. The sensation of motion would be produced by the way consciousness moves through this structure. Think again of a book. Each page exists before you begin reading. When you reach the final chapter, the initial pages have not ceased to exist. You have simply changed your position within the story. What if our experience of time works the same way? This possibility feels unsettling because it threatens one of the most fundamental ideas of human experience, the sense of time flowing freely. But this still does not resolve everything. In fact, it creates an even bigger problem. If past and future coexist, why do we only feel the present? Why does our memory point backward and never forward? Why do we remember childhood, but not recall tomorrow? This is where intuition begins to fail again. For a long time, it was believed that the answer was hidden only in human psychology. Today we know it may be related to one of the most important concepts in all of physics: entropy. Entropy is often described as a measure of disorder, but that definition oversimplifies the problem. A better way to imagine it is to think of a sandcastle built on the beach. There are countless ways for it to collapse, but very few ways for it to form spontaneously. The universe seems to follow this same tendency. Organized states naturally evolve into more probable states. It is precisely this statistical direction that creates what we call the arrow of time. But here, a new difficulty appears. The fundamental equations governing particles, fields, and forces often behave almost the same, whether run forward or backward in time. In other words, the basic laws of nature do not seem to have a preferred temporal direction. So where does the intense feeling come from that the past is behind us, while the future has not yet arrived? And this is only the next door to the mystery